Have you ever wondered what's really going on deep beneath our feet when a volcano erupts? It's not just a mountain blowing its top. It's one of Earth's most powerful and fascinating processes. Today, we're diving deep into the science of volcanoes to understand how they work and the massive impact they have on our world. So, what exactly is a volcano? Think of it as a vent or an opening in the Earth's crust. This opening allows molten rock, ash, and gases from below the surface to escape. This molten rock is called magma when it's underground. It's a superheated mix of minerals and dissolved gases stored in chambers deep within the Earth. Our planet's crust is broken into massive pieces called tectonic plates. Most volcanoes are found where these plates meet, at convergent boundaries where one plate slides beneath another. The subducting plate melts, creating magma. This magma is less dense than the surrounding rock, so it rises. At divergent boundaries, where plates pull apart, magma rises to fill the gap, often creating underwater volcanoes along mid-ocean ridges. But there's another type, hotspot volcanoes, like the ones that formed Hawaii. These occur in the middle of a plate, where a superhot plume of mantle material rises and punches through the crust. As the tectonic plate moves over this stationary hotspot, a chain of volcanoes is created over millions of years. Now, let's talk about the main event, the eruption. The explosiveness of an eruption depends heavily on the magma's viscosity, or how thick and sticky it is, and the amount of gas trapped within it. Magma, with low viscosity, like that in Hawaii, is runny. Gases can escape easily, so eruptions are often gentle, with lava flowing smoothly across the land. This is what we call an effusive eruption, creating broad, shield-like volcanoes. On the other hand, magma with high viscosity is thick and pasty. It traps gases, causing immense pressure to build up. When that pressure is finally released, it results in a violent, explosive eruption. Think of shaking a can of soda and then opening it. That's the idea, but on a planetary scale, these eruptions can blast ash, rock fragments, and gas miles into the atmosphere, creating steep-sided composite volcanoes like Mount St. Helens or Mount Fuji. The impact of these eruptions is immense and complex. Lava flows can destroy everything in their path, homes, forests, and infrastructure. But the danger doesn't stop there. Volcanic ash, made of tiny jagged pieces of rock and glass, can travel for hundreds of miles. It can disrupt air travel, cause respiratory problems, and collapse buildings under its weight. Then there are pyroclastic flows. These are superheated, fast-moving avalanches of gas, ash, and rock, traveling at hundreds of miles per hour. They are incredibly destructive and one of the deadliest volcanic hazards. Volcanic eruptions can also trigger tsunamis, landslides, and mud flows called lahars. But it's not all destruction. Volcanoes are also creators. Volcanic ash enriches the soil, making it incredibly fertile for farming. The heat from underground magma can be harnessed as geothermal energy, a clean and renewable power source. And ultimately, volcanic activity has played a crucial role in shaping our planet's atmosphere and creating the land we live on. From the fiery rivers of lava in Iceland to the towering ash clouds over the Pacific Ring of Fire, volcanoes are a constant reminder of the dynamic and powerful forces at work within our planet. They are both architects of our world and a force to be respected. Thanks for joining me on this deep dive into the science of volcanoes. If you found this as fascinating as I do not forget to hit that like button and subscribe for more adventures into the science that shapes our world. See you next time.